Hello guys, this is Neha. Welcome to my channel Guruaura. And in today's video, we are going to understand the term function from the chapter Relation and Functions. Let me start with a very common statement which we have heard in our science class. The function of the veins is to carry blood to the heart. Here, the word function refers to what something does or the natural purpose of something. But in maths, the word function has more specific meaning. In math, a function is basically something that relates or connects one set to another set in a particular way. But how exactly does function do that? Are all relations functions? So let's try to understand the concept of functions. As we know, a set is a collection of well-defined objects. Let's consider two sets A and B. Set A consists of the numbers 3, 4 and 5 and set B consists of the numbers 2, 4, 6, 9, 15, 16 and 25. Now, the set of all ordered pairs A, B such that A belongs to set A and B belongs to set B is called the Cartesian product of the sets A and B. So, A cross B is the set of the following ordered pairs. It's 3 paired with each of the 7 elements of set B. Next, 4 paired with each of the 7 elements of set B. And then 5 paired with each of the 7 elements of set B. We get the 21 ordered pairs. Out of these 21 ordered pairs, we see that in these 3 highlighted ordered pairs 3, 9, 4, 16 and 5, 25, the first element is a positive square root of the second element. A positive square root, that's the relation from set A to set B. Now let's do an arrow representation of the relation. Set A consists of the elements 3, 4 and 5. And set B consists of the elements 2, 4, 6, 9, 15, 16 and 25. The relation, a positive square root of, from set A to set B gives us these 3 ordered pairs. Now, thus we can relate 3 to 9, 4 to 16 and 5 to 25. Now, we have represented our relation in roster form, set builder form and the arrow representation. Let's find the domain, range and codomain for the relation. Domain is the set of all first components of the ordered pair belonging to R. Thus 3, 4 and 5. These 3 elements are the elements of the set domain. Next, range. Range is the set of all second components of the ordered pair belonging to R. Thus 9, 16 and 25 are the elements of the set range. And codomain. Codomain is the whole set B. Clear? Now let's check whether this relation is a function. To be a function, this relation must satisfy few criteria. Let's check them one by one. First, every element of set A has one and only one image in set B. Yes, this criteria is fulfilled. We can see that 3 has a single image 9, 4 has a single image 16 and 5 has a single image 25. Next, the domain of F is A. Yes, the domain of the function consists of the elements of set A. Okay, then no distinct ordered pairs in F have the same first element. As you can see here, no ordered pairs have the same first elements. 3, 9, 4, 16 and 5, 25. Here each ordered pair has distinct first element. So, as all the 3 criteria are met, so we can say that this relation is a function. Let's consider one more example and check if this relation is a function. Here, set A consists of the elements 2, 3, 4 and 5 and set B consists of the elements 3, 6, 7 and 10. And A cross B consists of this 16 ordered pairs. Out of this 16 ordered pairs, we can see that in these 5 highlighted ordered pairs 2, 6, 2, 10, 3, 3, 3, 6 and 5, 10, the second element is exactly divisible by the first. B is exactly divisible by A. That's the relation from set A to set B. Now let's do an arrow representation of the relation. Set A consists of these 4 elements and set B consists of these 4 elements. The relation B is exactly divisible by A from set A to B gives us 5 ordered pairs. Thus, we relate 2 to 6, 2 to 10, then 3 to 3 and 3 to 6 and 5 to 10. Clear? Here, element 2 has 2 images, 6 and 10, as well as the element 3 has 2 images, 3 and 6. Yes? But every element of set A must have only one image in set B. According to the first criteria, every element of set A has one and only one image in set B. So, this relation is not a function. Now let's check the second criteria, that is the domain of F is A. Again, the domain of F is A is also not met as we have no ordered pair with 4 as its first element. Now, the third criteria says no distinct ordered pair in F have the same first element. But here we have multiple ordered pairs with the same first elements, that is 2, 6 and 2, 10, and also 3, 3 and 3, 6 has 3 as its first element. So, all 3 criteria are not met, so the given relation is not a function. Now let's see which of the arrow diagrams given represents a mapping. Terms map or mapping are used to denote function. So let's see the first diagram. Here, A1 has a unique image B2, A2 has a unique image B3 and A3 has a unique image B4. Thus, each element of A has unique image in B. Therefore, the given arrow diagram represents a mapping, a function. Next, the element A1 of set A is not associated with any element of set B. So, A1 belongs to A. A1, the element A1 belongs to set A but does not have any image. As we have discussed, for a function from A to B, every element of set A must have unique image in set B, which is not true in this arrow diagram. So, the given arrow diagram does not represent a function. In the next arrow diagram, A1 has a unique image B3, A2 has a unique image B3 and A3 has a unique image B4. Thus, each element of A has unique image in B. Therefore, the given arrow diagram represents a function. Now let's check the next arrow diagram. Here, each A1, A2 and A3 has a unique image B4. Yes? Thus, as each element of A has unique image in B, therefore the given arrow diagram represents a function. Now let's see this arrow diagram. Here, in this arrow diagram, the element A1 of set A is associated with 2 elements, that is B2 and B3 of set B, and element A3 of set A is also associated with 2 elements of set B, that is B1 and B4. So, each element of set A does not have a unique image in B. Therefore, the given arrow diagram does not represent a function, or you can say a mapping. So, we can now define a function as a relation f from set A to set B is said to be a function if every element of set A has one and only one image in set B. Or in other words, a function f is a relation from a non-empty set A to a non-empty set B such that the domain of f is A and no distinct ordered pairs in f have the same first element. The function is denoted as this, read as function f from A to B or function f mapping elements of A to elements of B. That's all for this video. In the next video, we will work out few problems related to the same. Don't forget to like, subscribe and share my videos. Thank you.